Imagine a coin. It's a simple object, yet it holds a fascinating concept within its two faces. It has two sides, heads and tails. This binary nature is what makes it so interesting. In the world of computers, information is stored in bits, which are the smallest units of data. These bits function like tiny switches with only two states, 0 or 1. Just like our coin, they have two distinct possibilities. Each bit is like our coin. It can be either heads, which is 1, or tails, which is 0. This binary system is fundamental to how computers operate. Classical computers process information by manipulating these bits, flipping them between 0 and 1. This flipping is akin to tossing a coin and getting heads or tails. This is how they perform calculations and run programs. Every action, every command is broken down into a series of these binary decisions. Think of a basic light switch. It's a perfect analogy for understanding bits. It can be either on, which is 1, or off, which is 0. This simple mechanism is mirrored in the digital world. This simple on-off system is the foundation of classical computing. It's amazing how such a basic concept can lead to the complex operations that power our modern world. Now imagine a globe instead of a coin. A globe is a perfect metaphor for the complexity and vastness of possibilities in our world. Instead of just two states, heads or tails, a globe offers an infinite number of points on its surface. Each point on the globe represents a unique state, a unique possibility. This is much like the concept of quantum computing. This is where quantum computing comes in. Unlike classical computing, which relies on bits that are either 0 or 1, quantum bits or qubits are like our globe. They can exist in multiple states at once, thanks to a property called superposition. They can exist in a combination of states known as superposition, which allows them to perform complex calculations more efficiently. Representing not just 0 or 1, but a blend of both simultaneously, qubits can process a vast amount of information at once. Imagine a dimmer switch that can be not just on or off, but also everything in between. This is similar to how qubits operate. They can be in any position, representing a range of possibilities. This ability to exist in multiple states at once is what makes qubits so powerful. It opens up new horizons for computing, enabling us to solve problems that were previously thought to be unsolvable. Superposition allows qubits to explore many possibilities simultaneously. In the quantum realm, particles can exist in multiple states at once, unlike classical bits which are either 0 or 1. This unique property is what gives quantum computers their incredible power. Imagine searching a maze. A classical computer tries each path one by one. It's like a hiker exploring each trail methodically, taking time to find the correct route. This process can be slow and tedious. A quantum computer explores all paths at once, finding the solution much faster. It's as if the hiker could walk all trails simultaneously, instantly knowing the best path to take. This parallelism is a game changer in computing. Another strange quantum phenomenon is entanglement. This is where two particles become intertwined in such a way that the state of one directly affects the state of the other, no matter how far apart they are. Two entangled qubits are linked even if separated by vast distances. This connection is instantaneous and defies our classical understanding of space and time. Measuring the state of one instantly determines the state of the other, regardless of the distance between them. This instantaneous communication is what makes entanglement so fascinating and useful for quantum computing. This spooky action at a distance, as Einstein called it, is hard to grasp, but it enables powerful new forms of computation. Quantum entanglement could revolutionize how we process information, leading to breakthroughs we can only begin to imagine. With each additional qubit, the number of possible states a quantum computer can represent grows exponentially. A few hundred qubits could, in theory, outperform all classical computers on Earth combined. This immense processing power opens doors to solving currently impossible problems. Drug discovery, materials science, and cryptography are just a few areas where quantum computing could revolutionize our world. Quantum computing is still in its early stages, but its potential impact on technology and science is undeniable. The future holds exciting possibilities limited only by our boundless imagination.